Hello everyone, I hope you guys are doing well. So in today's video, we'll be walking through the multiple choice section of the 2025 VCE Maths Methods Exam 2. I hope this walkthrough actually helps you with your method study. If you find it useful, please make sure to like and subscribe for more videos like this, and feel free to actually share it with your friends or teachers because it really helps out the channel. And as always, if you are of course interested in private tutoring for methods, physics, chemistry or specialists, you can always reach me through this email over here. So in this video, I will be going through a lot of detail, like I will be actually taking my time, showing you my full thinking process and sharing like multiple ways to actually do some of the questions. So it actually supports, all students at different levels. And yeah, let's smash through this video. Alright, question 1. A function that has a range of 6 to 12 is what? So this is actually not even that bad because as you can see, it is just cosine functions. Now, for those that don't know, finding the range for sine and cosine are the most easiest thing ever. It's like the most easiest thing to find the range for sine and cosine because it's just a rule. There's a quick rule for it. Let me show you. If you ever get something like this, a normal form of, let's look at cosine, and this works for both sine and cosine, but let's give an example of a cosine. A cosine, x plus b. Can you see how A is our amplitude? And remember, amplitude is always going to be, when we take amplitude, B is our translation, of course. Remember, B, this one is our translation, Easy? So, if you want to find range, and this works for sine and cos, to find the range, it's this easy. What you're going to do is, you're going to take the translation, which in this case is B, and you're going to minus it by the amplitude, So, for example, if A is negative, remember, amplitude is always positive. So, if A is negative, it's always positive. So, it'll be B minus A and B plus A. How easy is that, So, it's translation minus A, B plus A. So, B minus A and B plus A. Let's give it an example, Let's do one example together. So, if I gave you 2 cosine, 2x plus 3. This is an example. Let's find the range quickly. So, remember what we're going to do? It's the translation. In this case, it's 3 minus the amplitude, which is in this case 2. And the same, 3, so the translation, plus in this case 2. And that is it. So, that is how you find the range, So, 1, 5. How easy is that? What about, I want to look at an example like this, What about if you have, let's say, a negative here, and even this one's negative? Okay, this is very important. I think this is where a lot of students kind of get confused. So what we're going to do is the same thing, B is our translation. Now, in this case, it's going to be negative 3 because it's being translated 3 units down. So negative 3 minus the amplitude. Now, be careful. It's not negative 2. Amplitude is always positive. So it's positive 2, So minus 2. And then the same thing, the translation, which is negative 3, but plus the amplitude 2. And that is it. How easy is that, So negative 5, in this case, negative 1. Easy? And that's how you actually find the range for both sine and cosine. It's that easy. Nothing too hard about that. All right. So in this case, they've actually given us the range, And they're just basically telling us, hey, which of these functions gives us this range? And we're going to do that, So for those that don't know, so what we're going to do, of course, let's do this one first. So what's our B? Our translation, it's the 6, because it's been translated 6, so 6 minus the amplitude, which is 3. And then again, so it'll be 6 plus 3. So that will give us what? So that will give me 3 and 9, which is absolutely rubbish. As we can see, it's not 6 and 12. So that it's not that one, so we can kind of eliminate this. Okay, let's look at the next one. So this one is the translation, in this case is 6. So 6. Minus the amplitude, which is in this case 6. And then 6 plus 6, which in this case gives us 0, 12, which again is not right because we want to get 6, 12. Let's look at the next one. All right. The next one is, what did I do there? Okay, let's look at the next one. So the next one, of course, as you can see, the translation is 9. Minus the amplitude, which is 3. And then it'll be 9 plus 3, which gives us what? That will give us 6 and 12. Aha, jackpot. Do you see how that's the same as what we want here? And there it is. So it's actually C as your answer. So make sure you put a circle on that. That is your first answer. Of course, you see how easy that is? Very, very easy type questions. And make sure you know this trick. It's actually really useful to do it quickly. And the same, let's just do this, might as well. So So remember, what's our translation? It's 9 minus the amplitude, which in this case is 6, and then 9 plus 6. And that is it. How easy is that? So that'll be 3, 12. What, sorry, what 12? 315. And that is it. Very easy. So C is your answer for the first one. Okay. Question 2. All asymptotes of the graph of basically this tan thing are given by what? Now, I'm going to show you I'm going to show you multiple ways to do this, yeah? If I was in an exam, of course, but I'm going to show you how to do it. Okay. So for those that don't know, tan graph has asymptotes that are vertical, yeah? Remember a tan graph? Just, it looks like this, yeah? Looks like this, where it has vertical asymptotes. Only vertical, not horizontal, of course, remember. Now, for those that don't know, if you have a function and it's a quotient function like this, quotient means like it's a division function like this. Like, in this case, like, you know, let's say, I don't know, x plus 1, actually, let's say just like 1 over x squared minus 1. If you ever want to find the vertical asymptotes, yeah, you know what you just do? You just take the denominator of the function and make it equal to 0 and solve for x. That's what you actually do to find the asymptotes for quotient functions. Quotient means division functions, for example, like this, yeah? So that would be, what's x squared minus 1 equals 0? So that will be x equals plus or minus 1. So that is our asymptote. Is that easy? Think of it like that. So in this case, yeah, you know how we know a tan graph has, you know, vertical asymptotes, but unfortunately, it's not like a quotient function. It's not a function that's being divided, you know, by something. So, that's a problem, or is it? Well, you can actually make it a quotient function. You can make it a division function. How? Because remember, what is tan? The definition of tan, you remember, tan x, yeah, is equal to what? Sine x over cos x. Aha. So what we can do, this, you know, tan function is kind of converted into this nice quotient function. And guess what? Take the bottom of it and make it equal to 0 and solve over our cas, and we will get our asymptotes, our general solution for our asymptotes. Isn't that so easy? So that's one way I'm going to approach it, and then I'll show you the other ways. Yeah? Easy? Let's do that. So what I'm going to do is I'm going to write this in terms of, you know, sine over cos. So look, so it'll be 2 sine pi x plus half, click that bracket, over cos pi x plus half. That's it. Look, we've rewritten this y in terms of that. And remember what we're going to do? We're going to take the bottom of our function. Let me make this nicer. We're going to take the bottom, this part over here, and make it equal to 0. Easy? So let's do that. Cos, and if we solve this, legends, we will actually get all our x values of our asymptotes, yeah? Let's do that. So, of course, I'm going to just use the cas. I can't be bothered solving this. Let's do it. So, I'm going to go to add calculator, and I'm just going to write solve, you know, cos, you know, pi times x plus half. So, half you can write as just 0.5, and that's it. Make it equal to 0, comma x. And here it is. This is our general solution. X equals n. Now remember, n here, if you're ever wondering, it's just like, it's integer. Like n is an element of all integers, yeah? So beautiful. We can write that, yeah? You can write it in terms of k and whatever. But in this case, we're going to write it in terms of k because, you know, that's how our solutions are written in terms. So let's write that. So x, you know how it's equal to n1? It's just known as k, where of course k, remember, is an element of all integers. We've hit the jackpot. Here are our solution. This gives us that, basically here it is. This is a solution for, this gives us all our asymptotes, yeah? Because k can be anything, like, because it's an integer, like whole numbers means, yeah? Like whole numbers, like -1, 0, 1, 2, 3, 4, 5, until you go to infinity, of course. But yeah, that is all our asymptotes, yeah? So which of them has that? Which, of course, it's A. Do you see how easy that is? A fits that perfectly. Not bad, yeah? Very, very easy to approach it. All right, that's one way we can, of course, approach it. Now, another way you can approach it is by kind of visual diagram it. Let's look at it through that way, yeah? Let's visually just draw a little graph and see what happens. And then we can kind of see what formula fits that perfectly. Let's do it. So also you can approach it by, okay, let's draw a tan graph, yeah? Let's just draw a tan graph. So let's draw this, like basically just imagine, forget about the translation. So let's draw just this graph here, 2 tan pi x, yeah? Like without the translation, of course, because then we'll do the translation and see what happens. For those that don't know, to draw like a tan graph, it's very easy. So we need to find the period. And remember, period is pi over n, where n is the number in front of the x, which is pi in this case. So equals 1, done. So it starts here. That's 1 here, legend. Yeah. And always half of 1. So you always half it. So if this is 1, what's half of 1? It's basically half. This is going to be where our asymptote is going to be occurring. Done. So that's x equals a half. Done. And of course, that's 0 and done. So it looks like this. Looks like this. And there it is. Look how nice that is. Of course, you can draw more. That's going to be, of course, x equals 3 over 2. And yeah, you can keep going and whatever. Like that. Yeah. All right. I'm just drawing a rough sketch, but let's do it. So x equals negative half. Negative 1. Okay, so let's look at this, yeah? So this is like a graph of y equals to tan pi x, yeah? And so what's happened then, it's been translated half units to the left. So imagine all those asymptotes. Can you see these asymptotes? Forget about everything. We're looking at asymptotes because we're trying to find the equation of our asymptotes, yeah? If you translate all those asymptotes like half units to the left, like for example, you know, this one over here, yeah? Imagine just like minus 1 from it, or like minus half from it, yeah? Like just minus half from it. Where would it become? It will become, of course, 1, yeah? So our new asymptote, think of it, our new asymptote for 3 over 2, if you translated half units to the left, it'll be x equals 1. What about this one here? If you translate a half units to the left, it'll be x equals 0, yeah? Because you minus half from it. What about this one? You minus a half from it, it'll be x equals 1. Here it is. Sorry, negative 1. I apologize for that. But yeah, as you can see, we've already got like 3 x asymptotes. And you can see that there's kind of this pattern. Can you see how it's negative 1, 0, 1? It's these integers, yeah? And then 2, 3, 4, whatever, yeah? So what we're going to do is we're going to try to check which of these formulas contains like 3 of these, yeah? And see if it fits this formula. Like, for example, imagine in an exam, yeah? Let's try D, for example, yeah? Of course, let's just try D. For example, if I something like k equals 0, this will go out, and so x will be a half. Aha, rubbish. There is no half. The whole, like, integers, they're all integers, they're whole numbers. These are asymptotes, there's no asymptote of half. Does that make sense? So that's already rubbish. We can kind of throw that in the bin. What about the next one? The next one, if for example, you sub in 0, perfect. If you sub in 0, like, it'll be x equals 1, which is an asymptote. What about, for example, negative 1? Like something, yeah? So 2, negative 1 plus 1 is negative 2 plus 1, which is negative 1. Rubbish. Do you see what's happened? So it's got these two, but what about the middle value? What about x equals 0? It's gone. It's never existed. That means it's not following the proper rule. Like, it's not following that rule. So also C is rubbish. What about the next one? Of course, the next one's also rubbish because, for example, if you sub in 0, yeah, to k, this will be perfect. It'll be x equals 0, done. What about if you sub in 1? It'll be x equals 2. Now, that's also an asymptote, but what about x equals 1? Did it just skip this? Absolutely it did. So that is rubbish, and only A fits that answer. Does that make sense? That's how you want to approach these questions. So a very visual diagram like this can really help out a lot. What about question 3? The graph of y equals f of x is shown. Beautiful. Which of the following options best represents the graph of y equals f of negative x plus 2? Not too bad. So for those that don't understand, let's just consider this as f of x right now, yeah? You know this graph here? Let's call it f of x. For those that don't know, f of negative x, if you put like, you know, f of negative x here, this is called also a reflection in the y-axis. So imagine this graph here, it's been reflected in the y-axis. You know this y-axis, just imagine you reflect it, yeah? For example, what's going to happen is, you know, this part here, so let me draw with the red line. So imagine, you know, this part here, imagine you reflect in the y-axis, it'll be over here. Perfect, like that. And imagine like this part here, imagine you reflect in the y-axis, it'll be over here, yeah? So it'll be like this. If I draw it nicely, actually, so it'll be like here. Of course, drawing a rough sketch, that's the point. And then what about this one? If you reflect in the y-axis, it'll be over here. Like that. And then doing the same here. So imagine like, for example, if this will be here, you know, if you're reflecting this, it'll be over here. And then reflecting this will be over here. Do you see how we've just reflected it in the y-axis? Imagine just a graph I reflected in the y-axis. And then what's happened is it's translated 2 units up, yeah? So if I plus 2 on it means I should take this graph over here and I just translate it up 2 units, yeah? Like 1, 2. Perfect. Jackpot. That is it. So which of the following graphs looks like that? Now, as you can see how it's crossing like the y equals 3? Which one has that? So this one's wrong. The other ones are all wrong, as you can see, but so it's only B because that fits the perfect shape, yeah? Look, both of these cross the y equals 3, but the problem is this actually has the right shape. You see, that's it's the same as that. And that is it. Very, very easy, yeah? Beautiful. Let's go to the next question. So question 4. Consider the following systems of equations below containing the parameter k, where k is an element of all reals. Find the values of k for which a system has no real solution. This is one of the most common questions, of course. Now, you could, of course, do this very, in a long method. Don't do it like in exam 1 where you will do all this algebra. It's only in exam 2. This is a multiple choice question. Do it as quick as possible. Now, the way I would approach it, to be honest, is because we're given, 4, answers, basically, or 4 multiple choice, choices, the way I would actually approach it is to think about it like this. It says, find a value of k for which these two systems of equations have no real solution. Let's actually understand what's happening here. Basically, what it means is, these two linear functions, here, basically, they don't intersect. No real solution means they never intersect. And for that to happen, these two lines must be parallel, yeah? If they are parallel, do you see how they'll actually never, even in the long term, never actually intersect? And so they will never have no solution or no real solutions. Makes sense? So they should have this kind of two important factors. First, they have to have the same gradient, as we can see, but also that their y values have to be different. Make sure to remember that, yeah? So their gradient, let's call it m1, must be equal to m2. So both gradients have to be the same, but their y values have to be different. Now, the way I would do it is generally just draw them in your CAS and sub those answers in and check which one has that has where the gradient's the same and the y values are different. And if the one that fits that condition, put it straight away, scribble that in as your answer, because that's all you want and that's all you have to do. It's that easy. Make sure you do it with your CAS. Please don't waste time by doing algebra. Not worth it. So let's do it. So what I am going to do is I'm going to go on CAS and I'm going to go on graph. Now I'm going to just go on graph interrelation. I'm going to write the first function. K times x, it says, plus 3y equals k squared. So this is the first one. Of course, I'm going to have a slider. Done, that's the first one. And the next one is 2x plus 2k plus 1 times y equals 6 minus 2k. Enter, and there it is. So these are two functions there. Now, let's try the first answer. So the first answer says k equals -2 only. Let's check that. Sub in -2. Okay, -2 actually is perfect. Can you see how they are parallel and they have different y values? Yes, -2 actually works. But because it says only, we just gotta double check all the other answers and then make sure it's only A. So let's double check the next one. The next one says B, for answer B. It says k equals 3/2 only. Let's check that. 3/2 only. Absolutely rubbish. As you can see, they're actually intersecting, they have the same gradient, they're on top of each other, as you can see here, but they're basically they have the same gradient and the same y value, they're on top of each other basically. And no, it's not just k equals 3/2 only. K equals -2, which was the first answer, actually also worked. So actually B is absolutely rubbish, and it's absolutely, this here we would consider as infinite solutions, not no real solution. Can you see how it's they're infinitely intersection? So you should know B is rubbish. Put that in the bin. So let me just cross that out. The next one says k equals -2, which we know it works, or k equals 3/2. Absolutely rubbish, because we tried 3/2 and it actually didn't work. Only k equals -2. So let's also get C out of the way. The next one say k can be anything except, or else means anything except -2 and 3/2. Absolute garbage. Rubbish. We know that when k equals -2, it works. Here it's saying it can be anything except -2 and 3/2, which is rubbish. So get D out, put that in the bin. It's only A. How easy was that? You see how easy it is? By basically using your CAS and just graphing them and just putting a slider. That is it. Very quickly do that in the exam, yeah? So that is it. Let's do the next question. Question 5. Which of the following sets represents a function that has an inverse function? Now be careful. Look at the wording here. Let's zoom in. Okay. So first they want the following sets to first have be a function and to also be an inverse function. Now, for a function, for us to have function, what condition do we have to meet? Does anyone remember? Remember, we have to use something called the vertical line test to check if it's a function. Let's give an example. Yep. So if I had a graph like this, yeah, and imagine I have this parabola. Beautiful. What the vertical line test is, you just draw vertical lines. And can you see how each of these vertical lines intersects the graph once? If each of those lines, those vertical lines intersects our graph once, then it is a function. But if it intersects it twice or more, we call it not a function, it's a relation. So for something like this is an example of a relation, yeah? So yep, like that. So for example, can you see how when we draw vertical lines, can you see how it crosses twice? It intersects twice, which is absolutely rubbish. This is a relation, yeah? Is that easy? Yeah. So first of all, so for us to actually do, like, for it to be a function, of course, it must pass also something called the vertical line test, yeah? Make sure you remember the vertical line test. It has to fix it. And let's look at the inverse function part here. So for a function to be an inverse, remember it has to be a one-to-one. And how do we make sure a function is one-to-one? Remember, we have to use something called the horizontal line test. Let's look at that, yeah? For example, if I draw a function like this, so parabola. Now, if we draw horizontal lines, can you see how horizontal lines are intersecting twice? Now, if they are intersecting twice, legends, this is not one-to-one. One-to-one is only when it intersects once. Every line intersects our graph once. Here, in this case, this is not one-to-one. Yeah, so hence it doesn't have an inverse, yeah? But what about if I get a graph like this in the example? Like, like this. Something like that. Now, of course, we use our, horizontal line test. Can you see how it intersects only at once at every point? This here, it's actually one-to-one, hence it has an inverse function. So in our case, legends, what we need to make sure is that our sets here has to also pass our vertical line test and our horizontal line test so we can make sure that all conditions are met. Yeah? Easy? So let's do that. How do we do it now? I'll be honest with you, it's very easy. What I'm going to do is I'm just going to draw like a Cartesian plane and actually just plot those points and see if they fit both, like meet both conditions. And yeah, if it meets one and doesn't meet the other one, it's wrong. So it has to meet both conditions, yeah? So what I'm going to do is I'm going to do this. I'm going to call this 1, 2, 3, 1, 2, 3, like -1, -2, and -3. Just something like that. Or what about like, -1, whatever you have to. Okay. Now let's just plot the first point, yeah? Let's do the first one. Check the first answer. It says 1, 3. So 1, 3 is this point over here. The next one is 2, 0. 2, 0 is right over here, as you can see. And the next one is 2, 1, which is over here. Okay. First of all, let's check if it passes the vertical line test to check if it's a function. So remember? Okay, first there's rubbish. Absolute rubbish. Why? You see when we draw the vertical line test, it crosses twice at these points, like it intersects twice at these points. And now remember what we said, if it intersects twice, it already has failed the vertical line test, and so it's not a function, it's a relation. So straight away 8 is absolute garbage. Garbage. Take that away, put that in the bin. Okay, let's check the next one. The next one is -1, 3. Let's check the next one. So -1, 3 is right over here. The next one is 2, 2. And 3, 1. Okay, now let's just double check the vertical line test. So if I do vertical lines, like in this case, this passes. Look, intersects once, perfect. So it's actually passed the vertical line test, so it is a function. Let's check if it's a one-to-one, so to have an inverse one. So, yep, that's perfect. Intersects once, absolutely legendary. It's both basically a function and has an inverse function. B is absolutely our answer. How easy is that? And now you can double check the other ones at your own time, but they actually would fail too. Do you see how easy that is? So make sure you look at the wording. That's how they kind of trick you in the exams, yeah? Beautiful. Next question, question 6. The trapezium rule is used when two trapeziums... The trapezium rule is used with two trapeziums to estimate the area bounded by the graph of f of x, the x-axis, and the lines x equals 0 and x equals 1. For which of the functions will the trapezium rule estimate be larger than the exact value? Now, this is actually not too bad, because I can actually do this with the CAS. Let's go to the CAS and do it with the CAS, because I'm not going to lie, I'm not graphing these. Straight up, let's use the CAS. So what I'm going to do first is we're going to graph them with the CAS. So let's do the first function, of course, like a, which is basically 3 minus e to the x, yeah? I'm going to graph this, and I'm going to just draw vertical lines at x equals 0 and x equals 1. So what I'm going to do is go to relation x equals 0, x equals 1. Yep. And just a little bit zoom in, of course. Let's zoom in here. Okay. And because we're trying to graph two trapeziums, yeah? Like basically try to graph two trapeziums, what I'm going to do is I am going to basically, you know how this is x equals 1? I'm going to half it. So x equals half. And this is it. Can you see how I'm going to break this into two trapeziums, like equal width of trapeziums? Yeah. And what I'm going to do is I'm going to just go on geometry, and to really look at my trapezium, I'm going to actually go to points and lines and segment. So I'm going to pick that point all the way to this point, and then this point, and all the way to this point. So can you see how the trapeziums are under the graph? And that is it. This is going to be one of the most easiest way to approach this question. Now, you remember what our goal is? We want which of these rules will have where the trapezium rule will estimate a larger area than the exact. Like, can you see how here? Can you see how the trapezium rule is actually smaller? Because can you see how the trapezium is below this function here? So you know what's happening? When you use the trapezium rule, it's actually going to be smaller than the exact area. which is wrong. Remember, we want where the trapezium rule is actually bigger than the exact area. So A is absolutely wrong. So make sure you do that. Let's try the next one, which is just basically, look, just replace the function. That's all we have to do. We don't have to do a lot of work. Just replace the function. And there it is. It's already done for us. As you can see, this is perfect. This actually meets the condition, because can you see how when you use the trapezium rule, the area of the trapezium is larger than the exact area, yeah? So actually B is correct, yeah? Is that easy? And you can, of course, just choose B as the correct answer. Now, of course, you could choose, try C, of course. You know, try C, try the other ones, but it's a really waste of time. Just make sure you choose the answer. Let's try just C, for example. 3 sine x plus 1. Enter. And as you can see, you know, the area of a trapezium is smaller than the exact area, which is wrong. So how easy was that, yeah? Just use your CAS, yeah? Beautiful. All right. So the next question is question 7. Consider the algorithm below. Beautiful. So we have this algorithm. In order, the values printed by these algorithms are what? Now, for whenever you're doing pseudocode legends, just please follow step by step. That's the goal. Yeah? Just follow it step by step. So this is how you want to approach these questions. Look. Okay, the first step says n equals 17. So I'm going to write it nice. Look, n equals 17. The next one says k equals 5. Yeah? Easy. Look, k equals 5. So now we're in a while loop. Now let me explain what a while loop is. A while loop is basically a loop where it has a condition like this, where it has a condition. Now, what you have to do, unfortunately, is if our values fit this condition, we have to go through this while loop so many times. We just got to repeat it infinitely until this condition is not met. When this condition fails perfectly, then we can end the while. Let me give you an example. Let's just do this example. All right. For example, can you see, like, okay, we got to start the while group because that's the next thing, yeah? Now we just, no, don't say that. Yeah. Now to do this, can you see how to start the while loop, it says you need to make sure that n is greater than k, yeah? And is that right? Let's double check. Is 17 greater than 5? Absolutely. So unfortunately, we have to use the while loop now. So the next thing is our new n value, which is n, is going to be equal to our original n value minus k. So for example, you know how 17 minus 5, and what's that, guys? That's 12. So this is our new n value. So you want to update this with 12 now, yeah? Easy. And then what you're going to do is rub that out. Okay, you see how we just updated our n value? And then the next thing is print n. Print it, basically, just write it. So our first n value is 12. Done. Now, of course, we can't end the while loop, yeah? Because we got to go back and keep repeating until this condition is not met. So we got to go back again to the top and do everything again. So is n greater than k? Absolutely. Still, that's condition. So is 12 greater than 5? Yes, it is. So we have to go through the while loop again. So where n, the next one here, is n is going to be equal to n minus k, which is basically 12 minus 5, which is 7. Yeah, so that's our new value. And then what we do, legends, is print n. So we print 7. How easy. And then unfortunately, we're going to go back to the while loop and check if that condition is still met. So is n greater than k? Let's check that out. 7 is greater than 5. Yes, it is. So we got to do again, yeah? So n equals n minus k, which is 7 minus 5, which is 2. So that's your new n value. And put that there. So we got to, and then we print that n value, which is 2. Done. And we got to keep doing it. So the next one is, again, go back to it. Is n greater than k? Is 2 greater than 5? No, it's not. So we've actually stopped. It's failed now. Do you see how the while loop, this condition has failed? So guess what? We straight away end it. And that is it. That's the file. That's our pseudocode. That's the whole code. And guess what? It says in order, what are the values printed by this algorithm? Here they are. 1272. Easy. 1272, which in this case would be, C. Easy. So just follow the code slowly and you'll do fine. You'll be actually fine. Question 8. A random sample of n Victorian household is taken to estimate the proportion of all Victorian households that will have vegetable gardens. The approximate 95% confidence interval calculated using this sample is this. So they've actually given us the 95% confidence interval, correct to 3 decimal places. The number of households n in the sample is what? This is actually so easy. This is like, they've given you a free mark, basically. Now, the way I would actually approach this is just make 2 simultaneous equations, yeah? Now, there's so many ways you can approach it. Of course, you can find the p-value, the sample proportion by, of course, adding those 2 confidence intervals and dividing them by 2 and whatever. Now, what I'm going to just do is, I'm just going to be lazy. What I'm going to do is, our confidence interval formula? So, our confidence interval formula, it's like, p hat minus z, which in this case, because we're doing 95%, it's just 1.96, square root p hat 1 minus p hat over n. And then imagine comma, and this whole thing, basically, again, yeah, repeated, but there's a plus here. Yeah, and that is it. You see? So this is our confidence interval formula, and what we can do is we can just take this one over here, yeah, and we know that it's going to have to be equal to this one over here. So 0.248. And then this one over here, this one has to be equal to, so actually let me make it nicer by kind of putting this here, 0.552. Easy. And that is it. So we've made two simultaneous equations and put them in your CAS. Like use let's solve substitutive equations and we'll find both p hat and n. Now we don't care about p hat to be honest, but n. We'll find n at least, and that's what we want. So let's do it. So we're gonna go straight away to basically go menu, and go to algebra, solve substitutive equations, and of course I'm trying to say p and n. Oh, sorry, p and n. So we're gonna solve and write those two substitutive equations. So p minus 1.96 times the square root of p times 1 minus p over n, and that whole thing equals to 0.248. And what I'm going to do is I'm going to just copy. Oh no, am I tweaking here? Let me just double check. Yeah, it's supposed to be equal here, sorry. So what I'm going to do is I'm going to copy this whole thing, paste it here, but now put a plus and then just change this to 0.552. Of course, there's a 2 equal sign here, and that's it. Press enter, and guess what? We found our n value and we found our p hat. Now, of course, we just care about the n value, which is actually approximately 40. So which one is that? So C is our answer. How easy is that? Very, very easy type question there. Okay, sorry, my thing is just, there it is, C. Beautiful, nice. So question 9. One day at a particular school, M students walk to school and the remaining N students travel to school using a different form of transport. Of the M students who walked, 20% took at least 30 minutes to get to school. Of the N students who used a different form of transport, 40% took at least 30 minutes to get to school. Given that a randomly selected student took at least 30 minutes to get to school, the probability that they walk to school is given by y. This is conditional probability, as you can see, just from the word given, just by looking at that word. Now, the way I would actually approach this question, this is actually not hard. This is like a tree diagram question. It's a very easy tree diagram. What we can do is just draw a tree diagram to represent this. Yep. For example, we have two things here. The student can, of course, walk to school, or he could not walk to school, or take something like a transport. And then, we have two parts to walking, of course. Also, so I can kind of duplicate that here. Okay. Now, when he walks, he can be at least 30 minutes. He takes 30 minutes, so like less, greater or equal 30 minutes to get to school, or of course less than 30. The same with this. 30 minutes or less than 30. Easy. Now, it says that the question says, one day at a particular school, M students walk to school. Walk to school. So we have, for walk, it's M over the total students. So M plus N. M plus N, because that's the walked, and N represents the people who travel to school. So, of course, the ones that walked, it's N over M plus N. Easy. And then, of course, the students that walked, it says, of the M students who walked, 20% took at least 30 minutes. Yep, so this will be 0.2% that walked. So this will be 0.8. The next one is of the N students who, of course, use different forms of transport, 40% took at least 30 minutes to get to school. So this is 0.4 and this is 0.6. Easy, because you remember that these have to total up to 1. Now the question says, given that a randomly selected student took at least 30 minutes to get to school, find the probability. So find the probability that they walk to school. So they walk to school, because they also said given, so we've got to put the good given, that that a random select student took at least 30 minutes. So at least 30. This is a beautiful question. What a beautiful, easy, nice question. So, of course, to use the formula, you remember for given formula, we have to find the intersection between these two. Yep, so probability of, so he walks and he, it's greater than or equal 30. And over divided by the right one. You know how this is our right one? Greater or equal to 30. Okay, beautiful. So, let's put a big division sign here. So let's find the top one here. So he walks and is greater or equal to 30. It's this one, yeah? Look how easy. Let me just draw it like this. Do you see that? He walks and it's greater or equal to 30. It's these two. So we can actually just write that down. So it's multiplying these two. So it's going to be M over M plus N times 0.2. Yep. And then divided by the probability that it's greater or equal to 30. There's two of that. Of course, it's this one over here that, as we talked about, it's greater or equal to 30, or this one. also where he doesn't work, and it's also greater than or equal to 30, so we can do these two. Now, of course, this is already done for us. We can actually just put it at the bottom, but we also have another one, so we got to put plus. I'm just going to copy that. Actually, let me duplicate it. Nope, that's not duplicate. Let me do this. Let me duplicate that here. Okay. Now, so I don't get confused. So this one's going to be n. Basically, this one's going to be n, yeah? Because it's this one, yeah? So it's n plus times 0.4. It's supposed to be 0.4. And done. So you put this in your cache and let it simplify it, and you should get one of those answers for that. It's actually not very hard. This one's, I actually like this one. This one's actually very, very nice one. I'm very happy with this one. So what I'm going to do is do it now. So it's n plus n times 0.2. Yep. And just take that, put it over here. Plus, same thing, but put an n here, and this is 0.4, and enter, and this is our final answer, m over m plus 2n, which one looks like that of our answer. It looks like A is our answer for question 9. What a beautiful question, very beautiful. Next question, question 10. Consider F where it has a domain of all reals, and this is f of x, and G has a domain of all reals, which is this. The inequality of f of g of x is greater than 0 is satisfied when what? Okay, let's do this. So f of g of x can be written as that. F of g of x like that, yeah? Is greater than 0. Okay, let's find f of g of x first. So it's basically 2, and you basically represent all the x's will be replaced with signs. So this will be sine squared x plus sine x minus 1 greater than 0. Of course, you know, this is quadratic, so we can actually just let u be sine x, yeah? So we can write that as 2u squared plus u minus 1 greater than 0. And so, of course, you're using, cross multiplication. So two things that multiply to give you 2u squared is 2u and u. And two things that multiply to give us negative 1 is, of course, like, negative 1 and 1. Multiply these two, yep. And then cross multiply. So what's 2u times 1? It's just 2u. And then u times negative 1 is negative u. And that equals u, which is the middle value. Beautiful. See, these are factors. So these two are factors right here, which is, I can kind of rub this out. And so this factorizes 2u minus 1, u plus 1. Let me write that nicely. There is u plus 1. All right. So that's nice. And so, of course, to solve inequalities, you can just kind of graph it, or you can just use your CAS, of course. Nothing too hard. So, of course, you can graph it. It's just a quadratic where it has a half. So this is u. So this is u. It's half, and this is negative 1. It's just normal quadratic that passes positive quadratic that looks like that. And of course, when it's greater than 0, it is from these two parts here. So here's the two parts. So this one and this one, because greater than 0 means like it's above the in this case x-axis or y-axis, like these two. So which you can write when you solve it. You can just put in your CAS. So it will be u is less than negative 1 and u is greater than a half, yeah? And remember, use sine x. You can kind of just bring it back. So the solution should be sine x is less than negative 1 and sine x is greater than half. So the answers look very, okay, in terms of sine, yeah? So actually, you know what should we do? Because they're not looking like these, our answers, what I'm going to do is do this. Make it easier. Because you know how we made sine x u? Why don't we do this? You know how u is sine x, yeah? Let's draw a timeline. What about if we just draw a timeline? And you can just remember, u is, again, sine x, yeah? So you just represent sine x. So like that. So man, this is u. Okay, let's represent these inequalities. So if negative 1's here, so it's an open circle. And, it's saying, like, because it's saying u is less than negative 1, so it means goes forever to the left. And u is greater than a half. So imagine this is half here. Open circle, and it goes forever to the right, yeah? So these are represented here. Now, basically what I'm going to do is just, if you know these, like, for example, let's check if this fits in within our inequality, yeah? And so it meets our condition, basically. Like, for example, you know how this first one, yeah? Sine x is less or equal to, you remember sine x is just known as u. So when it is u, let's write u is less or equal to negative 1. So let's represent that. I'm going to draw it now. So negative 1's here. So a closed circle only goes. Now there's a problem, legends. Yes, it fits, but the problem is this part here. It's supposed to be an open circle because it's actually not included in our answer. So it's not satisfying it. Does that make sense? So straight away, this is rubbish. Just letting you know that. So let's represent the next one. the next one's basically just saying, let's remember sine x is just known as, kind of replace this with u. U is between -1 and 0. Let's check that. -1's here, it's an open circle, and 0 is also an open circle, which is somewhere around here, and here it is. Now, there's a problem. It's not here, it doesn't satisfy, yeah? Can you see how this red square, it's not within our yellow lines? Our yellow lines is our satisfactory, but can you see how it's only satisfactory at this part, but all of this is rubbish, it's like out of it. So also that is wrong, yeah? Very easy, the way we approach this type of question. Next one is, again, represented as u. So it's between half and, oh my god, come on, get out of here. So half is open circle, it says, and 1. So +1 should be here, somewhere around here. It's going to be closed circle, it says. So is that right? Closed circle? And there it is, look. Can you see how that satisfies it perfectly, yeah? Can you see how that actually fits into our perfect set, like our yellow lines? Yeah, so it actually satisfies it. C is correct, by the way. That's beautiful. So C is absolutely correct. And we can, of course, you can double check the last one. The last one is basically from 0 to half. So half would be an open circle. 0 is over here. So also that's probably, yeah, look, these how it's not, yeah, it's not perfect. Easy. That's actually a very nice question. So yeah, beautiful. Okay, so let's do question 11. It says the chart below shows the daily prices of the stock market shares over a 30-day period. All right, looks nice. Over which of the following time intervals did the daily price undergo the greatest average rate of change? Okay, this is beautiful. Average rate of change. Now, to do average rate of change, guys, anytime you hear the word average and rate of change, of course, the first thing that should come to your mind is y2. It basically means gradient of y2 minus y1 over, in this case, x2 minus x1. Isn't that correct? So, yeah, basically imagine, for example, these 2 points here. So we want the highest. Average means, what that means, greatest means the highest average rate of change. So the highest gradient. Now, of course, this is quite easy because what you can actually just do is, for example, let's try A. You try all your answers first. You got to try all of them and calculate their gradients and then choose which one has the highest. Now, that's very long, isn't it? Yeah? Very, very long. Just imagine doing this. Like, like, for example, day 3, which is, this part here. Day 10, which is around here. And then you draw a number, find the coordinates. Like, imagine finding this coordinate here and finding this coordinate and putting in this formula. And that's only one. And you have to do it for the 4. You can do that, of course. But what I'm going to do is I'm going to visually look at them. Just visually. Because I can actually do that with the iPad, luckily. But I think it's much more harder in paper. So I think calculating just using y2 minus y1 is much more better and more guarantees the correct answer. So what I'm going to do, because I have an iPad, what I'm going to do is, okay. So look, can you see how this is our line, basically, for that day 3, which is 1, 2, 3. Yep, day 3 to day 10, which is 10's here. So I'm going to draw a number line right there that connects these 2 points. So this is my gradient. This is my line. This is how steep my line is. I'm just going to put it right over here. So this one's green. Let's make another color. So day 3, which is again still here, to day 17, which is 17's here. And I'm going to draw a number line on that. There it is. So this is the gradient of the next one. So I'm going to put it right. Can you see I'm just connecting the ends of it right there? Okay, so of course the green one's actually more steeper, so it has a higher gradient. Can you see how it's like taller, basically? What about day 14? Day 14 is right over here, and day 21 is right over here. Find the gradient of that, connect those 2 points, and what I'm going to do is bring that there, right over here. Aha! So actually the red one's actually larger. It has a bigger gradient, so greater average rate of change for all of them. Let's try D then, the last one. So day 14, which is over here, to day 28, which is, I think here. Yep, 30, yep, 28. So beautiful. Let's connect that and put that right too and see which one has the steepest. There it is. Aha! Oh. Okay. Let me double check that. So 26, 27, 28, 28's there. Yep, 14, 28. Done. Nice. So I'm just going to connect it here. Now, from what I'm seeing is, am I tweaking? Oh, it's correcting itself. I don't want it to correct. Yeah, there it is. Look, they're all connected. But can you see how our blue line, which is our last answer, is actually much more steeper. It's much more taller. It has a higher gradient, so greater average rate of change than all of them. So D would be correct. Now, that's just by visually looking at it for the iPad, of course. Of course, what you want to do to be more safer is just calculate y2 minus y1 for all of them. Yeah, it's not even that too bad. Yeah, easy. So, not bad. So, 11D. Next question is question 12. For a normal random variable x, it is known that the probability that x is greater than 200 is this value, and the probability that x is between 180 and 200 is this value, what is the mean and standard deviation for x? Now, I'm not gonna lie, this is a very typical question. You can absolutely just, look, it's a multiple choice. It's multiple choice. I'm not gonna lie. You want to go as quick as possible. You don't want to do some working out and waste your time. Like, how normally you would do it is by, drawing a graph and then, basically converting it into the z standard normal distribution, blah blah blah, making simultaneous. And this is a very typical question, but it's going to take long, and especially it's multiple choice. You don't want to do that. So what we're going to do is a dodgy method. What do I mean by dodgy? Let me show you. Because we only have 4 answers, it's one of them. It just has to be one of them. So what I'm going to do is do this. I'm going to, let's say A is correct. Let's just say A correct. So what we're going to try to do is we're going to try to use the A, like the mean of 190 and the standard deviation of 10, and we're going to try to find the probability that x is greater than 200 and see if it's equal to the value of 0.325. And if it is, then it's correct, See, that's actually being quick thinking. You want to do that. Find the quickest and the most easiest way to approach these questions, Because multiple choice are just one mark. You don't want to waste too much time on them. So what I'm going to do is do that. Look, I'm going to go to menu, I'm going to go to probability distributions, and I'm going to go to normal CDF, and I'm going to, of course, so my, we're going from 200 to infinity, of course, And I'm going to say, look, we're going to try the first one. Mean is 190 and 10, Enter. Guess what? That's not right. Because we want 0.325, Can you tell 0. That is absolutely wrong. So A is easily wrong. You see how easy it is? And so let's try the next one. So the next one's basically just copy and paste it. The mean is 190, but the standard deviation is 11. Enter. Still not the same. Get that wrong. That's B is wrong. You see how quick? The next one. So the next one is basically the mean is 195. The standard deviation is 10. Enter. It's close, but yet not close enough, because our answer is supposed to be 0.325. This is wrong also, so C is also wrong. And then let's try D, which basically just means that the only thing is standard deviation is 11. And this is absolutely correct, 0.325. So D is correct. Do you see how quick that is? You want to be as quick as possible in the exam, Find the shortest, most quickest method, Easy? All right. Question 13. The graph of f of x and g of x are sketched on the same axis here. Then whichever form could be the graph of g of f of x. Alright. And this is actually not too bad. You can actually quite be dodgy with it, because these two graphs, you can actually make 2 equations for them. Like, for example, f of x, It just looks like a y equals f, like f of x equals negative x, Do you see that? F of x just looks like a negative. It's a straight line of negative x, Just straight away pass through the origin. And then this one over here, g of x, can be easily, you can see that if we make up some values, like for example, imagine this is negative 1, this is 1, this is 2. You can write it as x, and it's positive, so x also across the x-axis. So x plus 1 for this one over here. I'm making the x minus 1 and x minus 2. You see how I made 2 functions, And what I can do is basically define those and basically go on graph, and what is g of f of x? This g of f of x, and then that is the quickest possible way that I would do. If I'm in an exam, do this way. Please do it. So for this, you need to know how to make equations, and I'll also show you how you would do it conceptually. And I'm not gonna lie, this is one of the most ugliest questions. So because it's nice that you can easily make functions for it and straight away do it with the cast, it's so much easier. But I will also show you the how you would approach it normally. But so let's do it. So what I'm gonna do is first let's define it. F of x is negative x, and of course g of x is x times x plus 1, x minus 1, x minus 2. And that is it. And so what I'm going to graph basically is g of f of x. And there it is. This is it. So which one looks like that, basically? From looking at my answers, that looks like C is our answer. Beautiful. You see how quick that was? Not even hard. Now, if I was... Let's go back. If I'm trying to do this, imagine I couldn't make functions for it, it's not as easy, and I couldn't make functions for it. How would I conceptually do it? I'll show you what I'll do. Okay, so let's first understand so we're getting g of f of x. This is what we want to graph, all right, let's importantly understand what will happen. So what I'm going to do is do this first. I'm going to say, okay, this value over here, this value over here, I don't know if it's 1, 2, whatever, but let's say this value over here, let's call it some value. I don't know, let's make it like 2. the y, look, the value is 2. And okay, like that, yeah? So I'm going to be like, hey, what is this value at 2? So like if I, sub it into my g of f of x, yeah? So if I subbed it, g of, it's basically f of 2. And see what it basically simplifies and what's the y value. So for example, what's f of 2 first? F of 2 means like this. You know how f of x is a straight line over here? It's basically subbing 2 into it. And if you sub in 2, what's our y value? It's going to be some very negative, like negative 4, let's say, yeah? So it will equal negative 4. Yep, easy. So that's the y value. Now, what is g negative 4? So g is the, this function here. And at negative 4, it's so far end. Like it's in the negative 4. It's on the far end. And what's the y value? It's a very high positive number. Meaning that g of negative 4, I'm going to say it's like a. I'm making it up, of course. But it's something with positive values, yeah? That means, guess what? Let me explain that. That means that when I sub in x equals 2, the y value should be 8. So in our original graph, so it should be some value here. Easy? So which one looks like that? So g of f of x, it's going to have that. This is absolute rubbish because if 2's here, it could actually be that one actually. Not actually, because I have some value over here. It cannot be that one. It's just by looking at it. Look, and then our C works perfectly. Do you see? If I add 2 over here, you can see it's like a y value. It's a very high y value. We just got to double check them. And okay, I mean, that wasn't the best value. I'm not going to lie because it's kind of, yeah, I'm not even sure if B's also. So we were going to choose a better value, actually. We're going to choose a better value to kind of work through it. So I'm just going to leave that there, actually. Just leave it there. Now let's look for another value. Let's say some value over here. Let's call this, let's call this 1. Yeah, let's sub in 1. So what is g of f of 1? What is f of 1? F of 1 means you go down to the f of x, and the y values, let's say, can you tell the value is like negative 1, basically? So we can say negative 1 here. And then what is g of negative 1? Imagine that, like, negative 1's here. You see g of negative here. And so you go to the graph of g, it's a very negative y value. It's a negative, like let's say it's like negative 2, basically. So basically we're at 1, so here. At 1, the y value should be negative 2, which is somewhere here. So it looks like this. Which one has that? This one, absolute rubbish. Can you see how there's no point here? So basically, it could be B though. It could be B. Now, of course it's not B because as you saw, what's happened is like the last time. And this one, look, it's perfect. You see how it's the Y value right here? It fits that perfectly. And it could also, but 100% A is wrong. Let's just be honest. A is wrong. Now, what I'm also going to do is I'm going to try a smart method to guarantee which one's correct at the end. I'm just going to choose a very, very large value on the right side, yeah? Let's do that. Let's just be geniuses here. Imagine I choose something like 5. So g of f of 5, yeah? If I do that, what's f of 5? F of 5 is such a negative y value. It's so negative. I'm going to say like negative 10, yeah? And what's g of negative 10? Negative 10 somewhere here. And g of negative 10 basically is if you have to go so high to reach it. So it's going to be like 20, let's say. The y value is 20. So it goes actually large. So when you add 5, add 5 here. Basically 5 here. Add 5 here. It's going to be such a large value. It means, yeah, it's going to look like that. It should go down like that. Which, of course, it's not B. It could have been A, but of course A was wrong. And it's not D because the more you go to the right, as you can see, it's supposed to kind of have that shape, which looks like C. Do you see that? Now, that's kind of hard. I won't lie with you. That's very generally hard, these type of questions, because I think this is the way you would approach it. But luckily, for that exam, it's actually quite easy to approach by just making functions for it. So 13 is C. Next question, let f be the probability density function for a continuous random variable x, where this is f of x. Let k be a positive real number, find the value of k. What a beautiful question. What we can do is, of course, define f of x in our CAS, and we know for a fact that if we integrate from, of course, 0 all the way to pi over 2 of f of x, we know that the area under the graph must always equal 1, and we can solve for k. Let's do that. I'm going to go to Control N and delete that. Sorry, what did I do there? And let's go. So what I'm going to do is first define this function. So that'll be basically k times sine x. Kind of copy that. Put that there. The next one is cos x. Then this one here is 0 less or equal to x less or equal to pi over 2. So pi over 4. And this is not, it's like less like that. Yep, just double checking it. Okay, nice. Taking that, putting it less or equal to x, less or equal to pi over 2. And there it is. So we've defined it, and we know that if we integrate it from, of course, 0 to pi over 2 of f of x dx equals 1. And we can solve answer comma k. Beautiful. And that's it. Root 2 plus 2 over 2, which is actually the same as b. Now, for those that don't know, this is just the rationalized. B is actually the correct answer, because if you just make this, take this and make it equal to the b of the answer of b, you can just double check it. So 2 minus root 2 is what? You see, it's true. They're the same thing. It's just rationalized, of course. So 14 is b. Beautiful. Question 15. The graph of y equals g of x passes through this point. The graph of 1 minus this must pass through. This is actually a very common question. So if you haven't done, please, and I beg you, do as many VCAR questions as much as you can. They are the gold. They are golden. You do them, these questions repeat. Let's walk through this question. This is a very repeated question that comes up a lot. So basically what we need to do is, okay, imagine g of x, yeah? We have the function g of x, and we have this point 1, 3. Easy. What's happened first is, let's try to do these transformations and see what happens to this point. So the first thing that I'm going to do is first, the 2x here. Now, for those that don't know, this is called a dilation, yeah? Dilation by a factor of half, remember you restrict parallel to the x-axis. Or you can say from the y-axis. But I like parallel to the x-axis. You know why? That basically tells me that the x values are all getting multiplied by a half. So g of 2 of x, which we just done here, what happens, did we say? The x values get multiplied by the half. So you know how this is our x value of 1? It gets multiplied by half, which is just basically a half. Done. So that is the first transformations, and we're making actually good progress. The next thing is, you can see that there's a translation, and to see that translation, you can just basically take the inside and make it equal to 0 and solve for x, and you can easily see the transformation. As you can see, the transformation is 3 over 2, translation 3 over 2 units to the right, yeah? Easy, yeah? So if we do that, so let's write that, g now it's going to be 2x minus 3. If you translate it 3 over 2 units to the right, basically the x value basically gets added up with 3 over 2 units, yeah? What's half plus 3 over 2 units? It's just 2. Nice, look how beautiful. The next one is that there's a negative in front of the g of x. For those that don't know, this is a reflection in the x-axis, yeah? Look, so what happens if you reflect something in the x-axis? Imagine you get this. Reflecting the x-axis, only the y values change. They become negative. So if I write negative g 2x minus 3, the y value, which in this case is negative 3, it will become negative 3. And the next one is 1. This is a translation 1 unit up, and of course, only the y value gets translated up. So you can write 1 minus g of 2x minus 3. And so it will be 2. If you negative 3 plus 1, because you translate it up, it will be negative 2. So 2, negative 2, which in this case has to be B is our answer. Very, very beautiful. Love it, love it. This question's a beautiful question. I'm just going to rub this out because it's a lot of stuff. All right, let's get into 16. 16. Consider the function h of x, which is this a log e b of x, where a and b can be anything except 0. Kind of makes sense. Given that the derivative, so h dash of x, has a range of 0 to infinity, which of the following must be true? So basically, the derivative function has to have a range of 0 to infinity, and we need to double check that it's always true or must be true. So let's do that. Okay, so we got h of x here. All right, so we got h of x. Let's just draw it nicely. So we got a log e b of x, yeah? And let's derive it. You know, just derive it. It's very easy. Remember to derive that. You can use it kind of your CAS anyway, but it's just a of x. If you derive it, because this a, multiply it, but how do you derive log b of x? Remember, you derive the inside, which is b, divided by whatever is inside, and you can see that the b's cancel out, and it's just basically a of x. Remember the quick rules that I've taught you here. Okay, we got that, yeah? Now, it's very important to understand. Let's look at the first condition. So a is greater than 0. Can you see this here? Let's double check that. Okay. A is greater than 0. Let's double check that. Say, for example, let's put a value, a equals 1. No, actually, yeah, a equals 1, yeah? Let's just make up a value. Like, let's make a equals 1, yeah? A equals 1. And, because it says a is greater than 0 only. So, you can have b as also positive, or b can be negative, anything, because it's saying only a has to be greater than 0. B can be anything, basically. Now, is that true? Not too sure, so we're going to double check that, yeah? So if a is greater than 0, and let's make b first positive, let's say, greater than 0, something like b equals 1, yeah? So a and b are 1, so it's basically a log graph, like a beautiful log graph. Now, because we made a equals 1, so this will be 1. Beautiful. So our derivative, if we're drawing, you know, the log e of x function, if you're drawing it like that, so you know how the log e of x looks like that. Beautiful. And when you draw the derivative of it, it's going to look like this. Remember, it's an exponential. Can you see 1 over x? If you draw 1 over x, we only draw that part. You know why? We don't draw this part because, remember, the exponential. It's a log, which only has that part over there. And it makes sense. Can you see how it's getting much less steeper as it goes forward? Beautiful. Now, beautiful. Can you see how this fits perfectly in our conditions? When a and b are positive numbers like 1 and 1, can you see how our h dash of x in this case is actually has the range from 0 to infinity? Do you see that? It's perfect. So it's true that a and b can be, you know, greater than 0. So that condition's actually met. What about let's check the other thing, yeah? Where now b, can it be negative, like less than 0? So for example, b equals, you know, negative 1. Okay, if that happens, that means this will be negative, and because you remember how this was a over x, this doesn't really change, because, you know, a is still 1. And okay, let's understand what's going to happen here. If I'm drawing this graph over here again, so basically this is now, it's being reflected in the x-axis, remember. And so when you're drawing the derivative, we don't draw this part of it, we draw this part of it. You see, because it's on the left side. And we just got to double check if it makes sense. So first of all, you can see it's slowed down, but it goes quicker. And yes, it is. It fits perfectly. Now, can you see when b is less than 0? Can you see how this is wrong? Where the derivative graph is actually, it doesn't have a range of 0 to infinity. It's actually at the bottom. So first of all, this is important. B cannot be negative. So straight away, this is rubbish because you know how this is saying B can also be negative? No, it can't. B cannot be negative. Also, this is wrong because it's saying A can be, you know, greater than 0. But what about B? It doesn't say anything about B. So it's saying B can be anything, but B cannot be, you know, less than 0. So that's also wrong. So it can only be C and D. Now, C is correct because we already know that A is greater than 0 and B is greater than 0. But we also need to check the other condition. So this is actually correct, but we got to check the other one. Okay. So the next one says that when you multiply a and b, it has to be a greater than 0 number. Now, in this case, like what we tried, yeah? You remember when two values are positive, yeah? As we tried last time, yeah? If our two values are positive, like 1 times 1, it's positive, yeah? It's greater than 0. But we can also have where a and b can be both negative, like -1, -1. Isn't that true? Because if that happens... So what about if a is negative and b is negative? Because if you multiply these two, isn't that going to be a positive number, which is greater than 0? So it also meets d as the condition. And let's check what happens. If we do that, this is what's going to happen. So this will be negative, and, you know, this will be negative, of course, -1, because you know how it's a over x. Now, a is negative. Okay, now let's think about what's happening here. All right. So how do we graph this? So remember, it's a normal graph, then it was reflecting the x's, and then reflecting the y. It looks like that. Okay, so it looks like this. Okay, beautiful. And then how do you graph this derivative part for it? So we know it's going to look like this. Yeah, like that. This part. Because you know how you draw it like that, the inverse, but of course you don't draw that part. Just got to double check it. So it's going, it's kind of, you can see that the slope is, and then it gets slower and slower. Yeah, that makes sense. No, yes, can you see how the range is actually from 0 to infinity? Also, this works. Where A can be, you know, where A can be both negative and B can be negative. If both are negative, it also works. So absolutely, this C is wrong because this is saying only A, and when A is positive and B is also positive, then it only works. But also, A can be negative and B can be negative at the same time and still work. So it's actually D is the answer. So just be careful with that, yeah? A very beautiful question, not too bad. Very great critical thinking question here. Let's do question 17. Given that, you know, basically f satisfies this, so it says from 1 to 2 f of x is greater than 1 to 3 f of x dx, the graph of f of x could be what? All right, doesn't seem too bad. So let's look at the first part. Let's look at A. It's saying from 1 to 2 f of x. Let's just look at this part. What's that? So 1's here, 2's here. So, okay, this is 1, this is that part here. 1 to 2 f of x. Now, it's like, because it's going to be like a negative value, -1, because it's below the x. Let's say it's -1, yeah? So this part is -1. Is going to be greater than 1 to 3 f of x. So 1 to 3 f of x is 1's here, and 3 is f of x here. And can you see it's basically all of this. Now, you can see that this is like -2, because it's like doubled, yeah? And it's negative. Let's still double check. Is -1 greater than -2? Yes, it is. -1 is larger than -2. So this actually works. So we can say A actually works. And I'm just going to put A as the answer first. We're going to try the other ones, of course, yeah? So you see how I'm going to work through this question? I'm just trying to check if they're all fitting that condition. Next one. So again, 1 to 2 f of x. Okay. 1's here, 2's here, and whatever's on the... Now, this is a positive. You can see because it's above the x-axis. Let's consider this as 2, yeah? as the value. Well, let's actually make it 4, something like that. Let's make it 4. So this 4 is 4 greater than 1 to 3 f of x. So okay, 1 to 3 f of x, let's kind of think about it. 1's here to 3. 3's here. So imagine, okay, that means we're taking this, the area of this, which we already know was 4. We'll also think of it like this. We're taking the area of this, below there, and with, okay. So there's kind of a, so that's 4 legends. And say this is like 2, and say this is like -1, because there's no, and so you just basically add them up. So that's like 6, that's 5. Like, if you add them all up, it'll be 5. Is 4 bigger than 5? No, it's not. So B is absolute rubbish. You see how easy that is? Kind of just doing like that, making up values, estimating, but it works. Next one, same thing. So 1 to 2 f of x, let's do the same with this one. Okay, 1 here to 2. So this area, let's call it 4, something like 4. So is 4 is greater than 1 to 3. Okay. So 1 all the way to 3. No, this is rubbish. So imagine just adding all these areas up. That's 6. Is 4 greater than 6? No, it's not. Straight away, C is rubbish too. Very, very easy. You see how these questions are quite easy? Next one, 1 to 2, again, do this. So 1 to 2 is this area over here. Let's call it like -2. So it's -2 greater than 1 to 3. So 1 to 3 is like, if that's -2 and this, let's say it's +1, add them up, it's basically -1. So is -2 bigger than -1? Absolute rubbish. So the only answer is 17A. Very, very beautiful. Actually, this is very nice, actually, for a question. So just be careful with that type of question and you'll be okay. 17A. Question 18. Consider the following graphs which represents a probability mass functions. Okay, this doesn't seem too bad. Which of the following, which pairs of the probability mass functions have the same mean? This is not too bad. So if you don't know, this is called a probability mass function. Basically, you know what we can do? For those that might get confused, what you can actually do is that you can make it into a probability table. Like these x values represent the top part, and this here represents the probabilities for those x values. Like for example, you can say there's 1, then there's 2, then there's 3, and then there's 4, and then there's 5. Yep, that's the x values, and then those are the probability. These values, those are the probability. And so to find the mean, you know what we just do? We multiply the x values by their probabilities and add them up, like what we normally do. Yeah, just showing you that it's the same as the table, but basically they're graphed. So this is not too bad. So let's do that. So 1 times 0.1 is 0.1, plus 2 times 0.4 is 0.8, plus 3 times 0.4 is 1.2, plus 4 times 0.1 is 0.4. And so by inspection, this here is 2. So it's 2.5. So the mean for this one is 2.5 for this graph. Look how easy that is. And of course, you can use your CAS, but it's so much easier just with my hand because it's not too hard. This one here is 1 times 0.1 is just 0.1. 2 times that is 0.4 because 2 times 0.2, yeah. 3 times 0.3 is 0.9. 4 times 0.4 is 1.6. Adding those two up, that'll be 2 and basically 3. The mean for this one is 3. Seems not too bad, yeah. Very, very nice. Keep going. Next one, this one here. 1 times 0.45 is 0.45. Yuck. 2 times, this is 0.25, yeah. So 2 times that is 0.5. Plus 3 times, that's 0.15. That'll be 0.45. Plus 4 times 0.15 is 0.6. So add those up, that's 1.1 if I'm not mistaken. Yep. And then that's 0.9. 0.9 plus that, it's 2. So the mean for this one is 2. Let's do that for this one. Yeah, it's the same. 1 times 0.2 is 0.2 plus 2 times that is 0.4. This is 0.6, 0.8, and 1 because 5 times 3. Yeah. Now adding those up, so like if you add those, that's 1. That plus 1 is 2. Then add that, that's 3. So the mean for this one's 3. seems not too bad. And so the ones that have the same mean is both these two here. So number 2 and number 4, which means 2 and 4. 2 and 4 is D is our answer. Not too bad, huh? This is a very nice question. Very, very easy question. Next question. Question 19. Let A be a point on the line y equals x plus c and b a point on the curve log e x minus 1. If A and B are placed such that the line segment between A and B has a minimum possible length, so the smallest possible length, and this length is root 2, find the value of c must be what? Now, look. You can do the algebra for this. It will take some time. Now, do you want to do that? Not really. Like, of course, you can make the algebra and you can sub in those values. That's actually the really good one. But what you can do is dodgy method. Let me show you what you can do. I'll show you how I would actually approach this question. So let's do it. So I'm going to go on my CAS here. What I'm going to do is go on a graph. And I'm going to basically graph the x plus c line like that. And I'm also going to graph the lateral log, like the log e x minus 1 line. There it is. I got 2 of these graphs. And of course, we have 4 possible values of c. So I'm going to try the first one, which is, root 2 minus 2, yeah? This one, yeah. And so here is the most possible. This is the smallest length, yeah, between the two curves, yeah? Like, imagine this is point, A, and this is B. So this is the smallest length, yeah? Now, how am I going to double check that? So what I can actually do is, I can go to menu, and actually go geometry, and I can make a segment, yeah? So I can go to, points on line, and I can go to segment, and I can point to here and all the way here, because this looks the smallest, yeah? And what I can do is I can find the length of it by going to geometry and go to measurement and go to length. And I want to find the length of this segment. Do you see how it says 1 unit? Sorry, why is it 1 unit? Yep, the length of this is 1 unit. 1 unit means it has a length of 1. But our one's, root 2. Our one's root 2, isn't it? Root 2, though. Isn't our one root 2? The length is root 2, which is around 1.41. So actually, if you sub in that, that's not correct. As you can see, let me just kind of zoom in so you can really much more see it. Here it is. So, I don't know where that went. Let me go back to geometry, measurement, and length. And there it is. So it's just one, let me put it there. So it's just 1 unit, as we can see, yeah? And look, the more you play around with it, it's not really, this is the shortest length though, yeah? Do you see? And yeah, it's not really, it's not like one, it's not, that 1.4 something. So let's try the next one. So A is not right. Let's try the next one, which is root 2, basically. Sorry, why is it root 2? Enter. And, ooh, no. This one's getting really large. As you can see, the shortest length would be somewhere around here, which is 2.41. Absolute rubbish. It's supposed to be around 1.4 something. So that's not right. Let's try 1. And so 1 also, it's very large. Look, 2.12. So yeah, let's try 0. 0. So bring it to the shortest length. Yeah, 1.41. Do you see how it's like this is this, basically because they are perpendicular. So this is the most shortest length. 1.41, which is around 1.426. Actually, 19 is D. That's actually the quickest method that I would approach this question with, just by doing that, by inspection. It's smart. It's a very quick way. So try it. It's a really approachable way you can approach. Of course, you could do the algebra for it, which will take some time, but especially it's a multiple choice. You want to really go quickly at it. Question 20. Let A be greater than 1 and consider the following functions f and g. Okay, this looks nice. Which of the following sequences of transformations when applied to f of x, so when we apply transformations to f of x, does not produce g of x? Okay, let's try them. So the first one is, let's try A. Dilation by a factor of half from the y-axis. Now, I don't like the word from, so I change it to curved way, like parallel. I'm going to write P for parallel, and I swap this with x. So when you swap like from to parallel, you have to swap, how it says y, you swap it with x. If it was x, you swap it with y. Basically, you know what's happening? So if to really understand it, it means all the x values are getting multiplied by half. So if you actually represented this into functional notation, so if we have f of x here, yeah, we would represent this as f of 2 of x, yeah? Like that in functional notation, yeah? So if we did that to this one over here, so it'll be, you're basically just replacing the x with 2x, done. And then it says a translation 1 unit to the negative direction of the x-axis. Basically, the next thing is basically x plus 1. So they're translating 1 unit to the left. So if we do that to this function here, so you basically just summon x plus 1 and then kind of expand that. And as you can see, yes, we absolutely get g of x. But remember, this is wrong because we want to make sure we don't get g of x. Which one does not give us g of x? So it actually worked. So that's actually good. So do you see how we can approach that? Let's try the next one. So the next one says dilation by a factor of half from the y-axis. Basically the same thing as that. So you remember, we can just write it as like g, f, basically like f of, kind of do that already translation. So like f of 2 of x. which is a2 of x. The next one is then dilation by a factor of a squared, not from, hey, from, parallel to the y-axis. It basically means all the y values are getting multiplied by a squared. So you basically multiply a squared in front of the function, yeah? So if we do that, what do we get? So because they have the same base, you basically add the powers. And so, yeah, this actually is the same thing. You can write it as 2x plus 2, which actually gives us the same as g of x. But remember, we don't want that the same as g of x, though. Very nice, not too bad. Very good questions. So this is actually just testing you how good are you with transformations. You need to be really good at transformations to do these type of questions, and they're not really bad. So I make sure to I make sure my students know how to do transformations properly, understand how to write them, and this is where it becomes very useful. Like if you don't understand them, you'll struggle with this type of concept. The next one is dilation by factor of a from the x-axis. So what I'm going to do is change this to parallel and then change this to y. Easy. So basically, it means all the y values are getting multiplied by a. So that would be like basically f of x, which means just basically a times a of x, which is a base, because it's the same base, the powers add up, so it's a x plus 1. Done. The next one is dilation by a factor of half, so remember, parallel to the x-axis. So basically, what's happening is we're saying f of 2 of x, basically, in this case. So if we do that, basically, you're just subbing 2 of x to this x. And then the next one is translation 1 unit to the positive direction of the x-axis, which is basically like f of x minus 1. So basically, you know, the x value, you just replace it with x minus 1 plus 1, and then expand that. And that gives you a to the power of 2x minus 1, which actually doesn't look like g, so absolutely C looks like the answer for that one. Very nice. See how easy that is? And that's how you approach it. Now, sorry, yeah, C is supposed to be the answer. Let me just... I don't know why I wrote that. Okay. We also do D, of course. Let's just try D. D is going to be not too bad. So dilation by a factor of a to the power 3 from the x. So remember, it changes parallel to the y. So basically, you multiply a to the power 3 to the a of x, which basically ax plus 3. Yep. And then your translation 1 unit to the positive direction of the x means translating 1 unit to the right, which you write it as f of x minus 1. So that would be x minus 1 plus 3, which is x plus 2. And then the next one is dilation by a factor of half from the y-axis. Basically, what you're doing is that you're multiplying the x, you're replacing the x with 2x, which actually looks the same. Look how easy that is. So it's C as your answer. Overall, I love this paper. Was actually beautiful. I didn't find it as hard. They actually found the question very manageable, very easy, 20 out of 20 for students. I think that, yeah, so I'm very, very happy with this paper. So really good paper, and I hope you guys enjoyed this video. Please tell me if you've enjoyed it. Have you learned anything from it? Please make sure to, of course, like and subscribe, and please keep watching these videos. They will absolutely help you. Believe me, they do. I've heard a lot of students tell me how much they are helpful, so watch them, grind on them, please. You'll learn so many new techniques, and yeah. Thank you guys so much, and have a great day. Bye-bye.